And it is an important subject. It might seem a little technical, but it's extremely critical for India to crack this particular puzzle to make the leap it wants to towards a developing nation, developed nation from the developing nation status that we are. So let me first dive into trying to get an assessment from all of you on where Indian manufacturing stands today. We typically hear this narrative that, it's a share of GDP in manufacturing is just 15, 16%, almost 15, 20 years, not much has changed. Of course, the size of the economy has grown, so manufacturing per se would have grown. But where do we stand today in terms of the global manufacturing landscape? Perhaps Abhishek from Rolls-Royce, with your global perspective, with plants in many countries, could give us some starting points.
Hello. Yeah. Thank you so much, Vikas, and thank you so much for inviting me here. And good to be with an eminent panel over here. So first and foremost, thank you. It's good to be talking about manufacturing. With everything going on AI, suddenly we feel very obsolete. So it's it's good that there are at least some sections of the crowd still interested in manufacturing. And because, as you mentioned, yes, so we are 15, 16, 17% of our GDP is manufacturing. And of course, the target is to get to 25%, right? And getting to 25% is going to be really important because we all know what manufacturing really brings, right? So there's an element of the economy, right? And I'm sure my eminent panelists can add more to it, in terms of how it helps with the multiplier effect, how it helps with the jobs and everything else. Then there's also an element of the consumption side of it, right? So that it's a sustainable supply chain, how it helps meeting the requirements of the electronics and everything else so that it meets the consumption growth requirements for a country like ours. And very importantly, and this is where I was going to, it's also about the overall element of the national security resilience, right? So with the current geopolitical elements, we have realized that it's becoming more and more important to have the Atmanirbharta, as we talk about, the self-reliance, in order to ensure that we have that level of strategic autonomy when it comes to national security resilience. So I think we as Rolls-Royce have been on a journey, and we have been working here for many, many years, starting off on this journey, and I'll speak a little bit more later. But what I can just say, to answer the question, because is that we have seen, because of a lot of concerted effort, both from the government and from the private sector in collaboration, we have seen a huge evolution in this journey. So what you see today is that where we were, say, a couple of decades back to where we are today, we are in that cusp of really moving up the value chain when it comes to manufacturing. And manufacturing can, you have different levels of complexity. And coming from aerospace and defense, what I can tell you is that today we are moving towards actually doing high-end critical technologies in India. And it is still going to be a journey. It's not something which is where we are already there. And I can speak a little bit more about the journey as we move forward, but we are definitely on the right path. We have the right kind of support that we're seeing from the policies. We have the right kind of support when it comes to whether it's the technology which is bringing in. And I think we have to continue with a lot of focus, think more about innovation and IP creation as we move forward.
Right. Mr. Kolar, do you want to weigh in on that?
Sure. Having me here, and I think well elaborated about overall manufacturing. I think I'll focus a bit on high-tech manufacturing for a minute. So I think we as a country are at a critical time wherein we have to make a choice, and that choice is not going to be easy. Globally, all the countries have been at a very comfortable position. You need a motor, you order a motor. You need a magnet, you order a magnet. You need an EV, you order EV. For the first time, we have seen in the last 12 months specifically that it might not work all the time. And it is a challenge how we become resilient and self-sufficient as a country, especially in high-tech manufacturing, so we don't get choked like the rest of the world has got choked in the last 12 months. And hope that everybody is hoping that world will go back one day to where it was 4 years back, 5 years back. But I think well and good if it happens, but I think the next 3 years you should take it as an opportunity and try to figure out what fits India, what suits us, and work with the materials available in India to make the products that we want to. So if you go a little bit deeper, we are at assembly and we are buying components. Now these components are made of materials, and materials, every material is made out of one of those elements on the periodic table, which comes from a mineral. We luckily in India have almost all the minerals, including the rare earths, which everybody has been speaking about. So the mineral is usually X value, and when you go to the purity required for these materials, it goes to 100x or 200x. So the value is not in the mineral, the value is in the process and the know-how to get the required purity, 99.999, whatever you need to produce these high-tech materials. So that is the know-how that we need to build. Luckily, uh, what we need is mostly chemical engineering skills. We need process engineering skills, which we are good at traditionally. We just need to refine on them. So yes, if we will get there, yes, we will get there. But I think the focus and impetus should be on, always on for the next decade, so that we don't have a similar challenge coming in the future. That is broadly what I feel where we are. We can discuss more specifics. Coming to what we do, so we exactly do that. We take a mineral and take it to purity as far as possible. Specifically, we are working on two materials. One is the silica. So when you talk about semiconductors, if you look at the elemental value of what is semiconductor made of? Element, it's silica, Si, that's it. So 90% of semiconductor is silica, but it's abundant in nature. But in nature, you get it 90 to 93% purity. Now here you're getting it, you have to go to 99.9999999s. So which means 1 in a billionth. You need a 1 in a billionth impurity in that material. So that is what we need to get to. So once you do that, I mean, entire semiconductor supply chain is with you, and you don't have to depend on anybody. Same thing with the rare earths. So to make EVs, to make motors, you need magnets. To make magnets, you need rare earth metal, oxide. So we are starting with rare earth oxides and trying to build on that. So I think we are focusing on two. There'll be a lot of products which the country can look at in purifying. It's no longer beneficiating. We were always beneficiating the ores. Now we have to purify the ores. So I think that is the challenge. I think we will get there. And one comment I would like to make is, if you look at the number of startups in India, which is 100,000, I think I just looked up it this morning just to look at a number. I think less than 50 are in advanced materials. So I think that specifically has to change for us to get to high-tech manufacturing or get that edge is what I believe in. Yeah.
Mr. Vikram, you as a you have a slightly more objective assessment as a financier, of how manufacturing landscape works. So,
Yeah. First of all, thank you for having me. And I was also wondering, what am I doing in a manufacturing panel? But, right now the banking is getting transformed, and we don't only finance companies, but we finance the whole ecosystem. That is from the project, the supply chain, the end product, and several other things. So, like you said, we are the objective person who touches manufacturing from end to end, from the inception to the whole working capital cycle to the further. So, yeah, it provides us a good bird's eye view of manufacturing from that perspective. And like I think all of us mentioned that India about manufacturing is about 17% of the GDP. And I think whatever I talk to my customers and this thing, I think, and also from whatever we are seeing from the government, I think we are on the cusp of a growth in manufacturing. There are a couple of factors. We as an international bank talk to our investors, talk to our international players, and all of them are looking for diversifying the supply chain. And India continues to be a market which they're looking and comfortable for sourcing. I think the second factor which is working for manufacturing is the government push and the various policies. We saw the national manufacturing policy which came out in the last budget, the Gati Shakti, and several other initiatives which the government has done. The PLI scheme, we've seen the benefit of that. So there's an acute support from the government and part of the Viksit Bharat program to encourage manufacturing in India. The third, and we had the big AI summit in India. I think India, from a data perspective, is a very evolved country. We just need to use that data properly. And I think with all the focus, that would be another enabler for us to become a good manufacturer. And third, I think, which is there is our labor force and the cheap labor which we have in the country. All these 4 and 5, I think, are good enablers for us to become a global manufacturing hub.
Right. So, do you think, I mean, with the policy push from the center, we're also seeing states being highly competitive nowadays, trying to get the right investments, trying to create the facilitating environment to make it easier to set up shop and start operations. So, what's your experience been? Maybe we can start with Mr. Kolaredi and then move to.
Yeah, sure. So, Center has done a great job in setting up the PLI scheme. I think this is that faster adoption and commercialization. So let's look at an example of your cells, right? LFP cells. So technology is basically owned by Chinese companies, and we are building on that and building scale to gigawatt scale. But still, technology is not ours. So this helps us in catching up to some extent, and the helping the rupee to supplement the imports. But similar to PLI, let's say we have something called R&D linked incentives, right? Which I think is the gap today. What that could do is in 5 or 6 years from now, we might leapfrog. So is any company working on solid state today, right? So what will happen, all these technologies get redundant in 5, 6 years, then again you have to get some technology and start developing those. And we, at the cost of the funds that we get in India and the kind of margins that Indian businesses expect, you can't keep churning a technology every 5, 6 years unless it's your own. You'll have to pay a premium to whoever is giving you the technology. So I think that is one. I think a missing link. I think government will be looking at it shortly. R&D linked incentive so that we see a huge R&D push from companies as well as. So this can be done by central government, not by states. So I think that is the biggest push required. Yes, states are. Some states are very aggressive, like where we are from Andhra is very aggressive in inviting businesses and give them infrastructure. But states have a limited role in high-tech manufacturing. So what the state can do is give its share of the GST, which is 50% of the overall GST as a subsidy. It can give land. Maybe it can create some power infra, but what more can it do? So I think overall, like PLI, larger scheme is important, where I think the states also will fit into that. But I think some states are doing an amazing job. So wherever we are quite happy.
Right. Mr. Singh, high-tech manufacturing needs more central than state support.
I think it requires an equal proportion, both of them, right? So, for example, we at Rolls-Royce, we are there. We have some of our manufacturing setups in India, joint ventures. One of them is in the defense corridor in Tamil Nadu, Hosur. So we are growing over there. And what we're doing over there is high component manufacturing. So earlier we started off with, I would say, simpler parts. I won't say low-end parts, but simpler parts, and which were static parts, not high temperature parts. But now what we have seen is that we're moving towards some of those more complex, fast moving, high temperature parts that we are looking at, right? So having said that, I think there's been a lot of support, if I'm honest with you, that we have had from the state governments, whether it is on the subject of land, also from the subject of skilling. So in terms of how they're supporting us with the skills that are required across the complete, manufacturing chain that we have set up. And what I would like to bring out is what's been really heartening from a state side is that over the last, I would say 3 to 4 months, we have had at least 4 or 5, state representatives traveling to UK, discussing the opportunities to really invest in India, in their specific states, right? And also kind of, talking about, what is the kind of infrastructure that they're setting up, because these manufacturing hubs to work, they have to work like an ecosystem. It has to be a hub. You cannot be completely diversified, geographically. You can still be, but the efficiencies come in when you start kind of co-locating, working in that manner. So what we have noticed is that there has been a lot of push, and as I said, multiple state governments have approached us with various, I would say, schemes that they have been trying to put together to help grow this. So I think states doing the job, and I think center, as we know, the union's doing a fantastic job anyway. Yeah.
Right. Mr. Vikram, just wanted your assessment of where you know if you look at India's trade basket, we import a huge amount of goods from China. And many of those goods, if you look at some of the recent quality control orders that have been issued, include things like screws, nuts, and bolts, the very basic manufacturing capacity that we should have. So, on one end of the spectrum, we are doing high-end work for, say, Apple. We're putting together Apple phones and, iPhone shipments from India at record levels. And on the other hand, we can't make a good scissor in India. We can't make a screw or nut or bolt without Chinese imports. So is there something that we're missing in this picture?
So I'll continue with the example which you mentioned, and the customer which you mentioned, which is assembling now, will be assembling 20% of the iPhones in India. So I had met them and asked the same question. So they're saying that for us, cost competitiveness is the best. And in terms of if we import a low value item from China and do the value addition here, that is more important for them than have the whole ecosystem in India. In terms of they are more focusing on doing the value add assembly and all that in India, and they're okay whether it's China or others to import the low value added command. So I think it is coming to the theme is that what India is moving up the value chain in terms of basic material and assembly. We are moving to the high end work, and I think that probably and the value added stuff and the technical stuff, because the way they explained to me, even making the assembly and the phone of the cover of the iPhone is also very technical. So they're focusing on the more technical part in the whole assembly rather than the basic ones, and which is what gives the value add. So I think from that perspective, the Indian promoters or the entrepreneurs or the companies want to move up the value chain and focus on that.
So to take that thought forward, Abhishek, could you tell us a sense of, how does Rolls-Royce figure out,
Yeah.
what it wants to make in India, what it wants to do in a plant elsewhere, and
Absolutely happy to. And so let me share the journey, probably make it a little bit more real in terms of, something that we've been doing. I'm sure there are various other models that are also followed. So I think we started in 1965. So when you look at it, you have to look at it as a complete life cycle, and then you have to look at the value chain, right? So when you look at the whole life cycle, we started somewhere in around the 1956, if I'm not wrong. And over there, we started off with the assembly and test, right? And we are talking about an aerogas turbine, as you would appreciate. It is extremely complex, but it was only assembly and testing part of it. So when you look at the complete life cycle, it falls on the right. Over the last few decades, the journey has continued from there. So what we have been doing is really looking at a backward integration. So starting off from assembly and test, then we got into more in terms of production and then manufacturing element of it. Again, in manufacturing, as my esteemed panelist was talking about, if you look at it, starting off from raw material to castings and forgings, getting into machining and then special processes. So there is quite a bit of a complexity that falls in it. So we started off again over there with things like doing, simple machining, as I said, but slowly and steadily, we are again moving in the complete value chain over there to get in more complex elements to it, right? Again, coming back to the life cycle from manufacturing. Now, this is where we have started becoming a little bit more, I would say, getting into the advanced technology element, because what we are talking about now is about co-creation, co-development. Because if we have to get into high-end manufacturing technologies, we have to own the IP to a large extent. So it's about product innovation, it's about process innovation. So now the model that we are following is about co-creation in India, wherein the IP is owned by India, right? So that's the new model. So that is on the design and development side. And then we have a lot of work wherein we are actually working with the academia to get into really low TRL level as we talk about technology readiness levels. So how do we really work on those technologies? So there's a lot of work going on with academia. There's a lot of work that we're working with the other industry partners. And we're trying to see how we can work in a kind of a design complex kind of a scenario so that that research and development can also happen in a sustainable manner for the future. So this is the kind of a journey, and I think we have achieved a lot. There's still some distance to go and some I would say, additional elements which we can focus on to accelerate this journey. But yes, that's the journey for us till now.
Right. Similarly, you said, the critical minerals processing, clearly the technology is generally dominated by China. And I think the whole world relies on it for most of the rare earths that are processed. And you're hoping to bring that to India and at least start the journey. So I want to understand from you, uh, one, this obviously is a starting point to deepen the value addition in this critical sector. But at what stage and what kind of research help do we need to sort of start developing our own technologies? You said it is hard to change the technology every 5, 6 years. If you don't have it, it's not your own. And is there an effort you see, or for instance, critical minerals are needed for EVs, for so many other applications that India is gung ho about? Then what are we doing to make sure we have enough internal processing capacity? We are looking at mining on the minerals, auctions are happening and so on, but we still don't get much out of the lithium if we can't process it ourselves. So how do we do that bit?
Yeah. So I think we'll start with lithium since it ended there. So lithium or LFP cells were basically a technology. It's almost 25 years old, 15 years into commercial, and the whole tech was developed in some part of the world, then adopted by China and commercialized. Right. During that time, they acquired literally 80% of world's lithium resources. So the tech is theirs. They have the access to the supply chain, and they built on that. We don't have lithium, unfortunately. We have rare earths, we don't have lithium, not much. So coming back to the first point that I made, that we are at a point of time wherein we can build hundreds of gigawatts of lithium cells, okay, that's a good start with PLI. But we don't have lithium. So what do we do? So we need to work on materials that we have. What do we have? Now, okay, we don't want to start on a white paper. There are a lot of R&D projects, there are pilot projects, there are small commercials doing solid state batteries. And what do you need there? You don't need so much of lithium, number one. And you can replace a lot of lithium with, let's say, silica. Now that takes 3 to 4 years to commercialize. We should start there. So if we are in this loop of increasing the efficiency of density in lithium batteries and going down that path only, then we will be at a point of time where we have to depend on lithium even today or in the future with somebody. So we know what minerals we have, we know what materials we can develop, and with that, can we develop the products we want? There will be products which we cannot technically. We just, okay, fine, that's something that we'll have to live with, but at least do what we can. Fortunately, again, coming back to it, a lot of things we can do. So coming back to rare earths, so India has a huge mineral sand beach, and it has a lot of rare earths. And I think we'll be not only self-sufficient, we can export globally. To understand the context, today China is producing 60,000 tons of rare earth oxides. India is producing 500. The global requirement is 75,000. India, and it's increasing at 12-13% year on year. So assuming that by 2031, that number is going to be 120,000 globally. If you're asking me whether India can take 25% of the global market share, yes, it can, and sustain for the next 50 years. So those are the things I think we are working on, and a lot of other companies are working on. Process the beach sand, extract the monazite, convert into oxide. So the PLI scheme recently announced is from oxide to magnet. There is no oxide. So for example, the PLI scheme, which 5 companies being awarded 6,000 tons will need 4,000 tons of oxides. Today we're producing 500. Where will the balance 3,500 come from? So those are the problems we're trying to solve on the supply chain, deep supply chain, wherein this material is handed over to the industry. And from then on, it's mostly capex, energy, and ramp up, and some technology going beyond that. So I think that's how we are looking at the whole thing. Same thing with silica. As I said, semiconductor is 98% silica. A sensor is 90% silica. So we're talking about electronics manufacturing. Are we making sensors? Why are we not making sensors? So again, you need high purity quartz for that. Right. So that is where we are looking at. That is the direction we are heading in.
Mr. Vikram, at Maastricht, how do you view the India's attempts to deepen the value addition and supply chain integration in its production systems? How do you view the impact of the turbulence that we've had over the last 1 year? And it seems like we'll have another year of difficult trade environment. It makes it tougher for investors to make long-term supply chain decisions or invest afresh in new geographies.
Well, the good part is that from a Mashrak's perspective, we deal with the global players, global investors, global supply chains. So while the good part is it's not only India, I think the world has had like a uncertain period. In that, I think India has been relatively better placed. And I think our handling of various situations, the tariff situation and others, have been applauded by global investors that India has acted very, very maturely and has worked very well to sort of have several bilateral trades and other agreements closed out. So it is a turbulent time for the world, but I think the confidence and resilience in India still is there. And I think our governance, local laws, democratic setup, I think all are encouraging for the investors, and like even the government and the others are also very encouraging. So I would say it's been a turbulent time for the world, but relatively better placed. People have gone slow on their plans, but they continue to focus and continue to grow and invest in India. In fact, we did a roadshow for India across, and the interest was tremendous.